Okay, so in this video, we're going to look at dimension. Dimension. So first of all, what is dimension? Dimension simply means expression of physical quantities in terms of fundamental quantities, right? It is the expression of physical quantities in terms of fundamental quantities. That's what dimension is. You express physical quantities in terms of fundamental quantities. So what are fundamental quantities? Fundamental quantities are basic quantities in physics. They are basic quantities that cannot be defined in terms of other physical quantities. In other words, they form the foundation for expressing all other physical quantities. So fundamental quantities, they are those basic quantities. The word fundamental simply means basic. So they are basic quantities, or they are those primary quantities, or they are those elementary quantities that cannot be defined in terms of other physical quantities. So they are independent of what? Other physical quantities. And they form the foundation. They form the foundation for expressing all other physical quantities. So the basic fundamental quantities that we have in physics, they are mass, length, time, electric current, temperature, amount of substance, then luminous intensity. So all these seven, you must take note of them. We have mass, length, time, electric current, temperature, amount of substance, then luminous intensity. These are the seven basic fundamental quantities in physics. So you must take note of these seven. Then, the fundamental quantities in physics, like I said, they are seven. They are basically seven. They are more than seven anyway, but we're looking at seven major ones. So we have mass, length, time, electric current, temperature, amount of substance, then luminous intensity. These are the seven basic fundamental quantities. Then here is the dimension. The dimension for mass is m. The dimension for length is L. The dimension for time is T. The dimension for electric current is I. The dimension for temperature is theta. So it's theta. The dimension for amount of substance is N, and the dimension for luminous intensity is this J. So you must just know this. Know the fundamental quantities and know their dimension, right? So here we are looking at the dimension of derived quantities. So the first question that I have here, what is the dimension of speed? What is the dimension of speed? Speed is an example of a derived quantity. And what is dimension? Expression of physical quantities in terms of fundamental quantities, right? So these are the fundamental quantities and this is their dimension. So what we do is to express the derived quantities in terms of fundamental quantities. So what is the dimension of speed? The first thing you want to do here is to write out the formula of speed. So you have speed to be equal to distance over time, right? Speed is equal to distance all over time. Distance is length. Distance is length. So the dimension for distance is L because it is length. It is a fundamental quantity. So this will be equal to L, which is the dimension for distance. It is length. The dimension for length is L. Then time, the dimension for time is what? T. So my speed, the dimension for speed will be equal to L over T, or LT raised to the power of minus 1. So LT raised to the power of minus 1 simply means L all over T. So this is my dimension for speed. We have just expressed it in terms of fundamental quantities. LT raised to the power of what? Minus 1. What is the dimension of velocity? So you should know that velocity, the formula for velocity is equal to displacement, velocity is equal to displacement over time. So displacement is a fundamental quantity. It talks about length. right? Displacement, the distance moved in a specific direction. So displacement is length. So the dimension for displacement is L, which is length, over the dimension for time is what? T. So the dimension for velocity is equal to L over T, or LT raised to the power of what? Minus 1. So this is our answer to this question. It's either L all over T or LT raised to the power of what? Minus 1. This is the dimension for velocity. What is the dimension of area? So area, you have area to be length times length in terms of a square, right? Length times length, length times length. So the dimension for area will be equal to L squared. This is the answer. We just expressed it in terms of what? Fundamental quantities. Then what is the dimension of volume? So volume is equal to, let's say the volume of a cube is equal to L times L times L. L times L times L. So the dimension for volume is equal to L times L times L will give us L raised to the power of 3, which is L cubed. This is the dimension for length, for volume. Then let's take this last one. What is the dimension of force? So force is equal to mass times acceleration. This is the formula for force. Mass is a fundamental quantity and the dimension is what? Is m. Acceleration is a derived quantity. So we're still going to express it in terms of fundamental quantity. So acceleration is equal to velocity all over time. Acceleration is equal to velocity over time. And your velocity is equal to displacement over time, right? So if acceleration is equal to velocity over time, and then v is equal to d over t, which is displacement over time, then my acceleration can be equal to, instead of me to write v here, I will put the fundamental expression here, which is d over t. So that is d all over t. That's for my velocity now. Velocity is equal to d over t, which is what you can see here, times t. That will give us the acceleration. So acceleration will be equal to d over t times t. The dimension for displacement is what? L. The dimension for time is what? T. And t times t will give us what? T squared. So the dimension for acceleration is L all over t squared. So that will be L over what? T squared. This is the answer. Or you can write it as ml t raised to the power of what? Minus 2. When this comes up, it becomes minus. So that's why you have this ml t raised to the power of minus 2. So with this, we are done with dimension, right? Like I said, dimension is simply expression of physical quantities in terms of fundamental quantities. So one more important thing that you should know is to know the formula of the different derived quantities. So the formula for area is length times length. Formula for volume is length times length times length. The formula for momentum is mass times velocity. The formula for impulse is force times time. Formula for electric charge is current times time. The formula for speed is distance all over time. Formula for velocity is displacement over time. Acceleration is equal to velocity over time. Force is equal to mass times acceleration. Work done is equal to force times distance. Power is equal to work done over time. Pressure is equal to force over area. The density is equal to mass all over volume. So these different formulas for these different derived quantities you must know in order to write out their dimension. So with this, we come to the end of today's lesson. See you in our next lesson.